Hello class and welcome to today's lesson on 7.1. We're going to be talking about today ratios and proportions. Our objective today is to write ratios and solve proportions. Our essential question is, how do I write ratios and solve proportions? So to start here, right, what is a ratio? A ratio is a comparison of two quantities by division. It can be written in three forms. So right, notice we have A and B are representing two numerical values. So we can either write it as A over B, A with our colon in the middle, and then A to B. So those are our options here. So what we're going to do is start by writing a ratio here. So it says, what is the ratio of the length of the toy car to the real car? Be careful of units. So starting here, I'm going to back out for one sec. All right, looking here, we have a car that is 4 inches, that toy car there. So you have a toy car here that is 4 inches, and then notice our real car is 12 feet. So what we need to be careful about is if we're going to compare the two, we got to have the same unit of measurement. So we're going to start here with this, right? We are going to convert 12 feet into inches. And right, how I did that, right, for every 1 foot, there are 12 inches. So we multiply 12 by 12, and that's how we get to this 144. So notice now comparing toy car to real car, it's 4 inches over 144 inches. What we always want to do with ratios is reduce it as best as we can. So they're actually both divisible by 4. And so our final ratio here can be 1 inch over 36 inches. All right, again, you're welcome to write it in any way that you like, right? We have 3 options here, right? Either like this, A over B. We could also write it like this, as 1 and 36. And then we also can write it like this, 1, 2, 36. So there's one example here. So we're going to move on to the next one. Dividing a quantity into a ratio. So it says Minnesota Twins hope to have a season where their win-loss ratio is at least 5-1. If they play 162 games in a season, how many games minimum do they hope to win? So what we need to do first is we need to figure out, right, using this ratio, how we can set this up and solve for this. So how we're going to set this up is giving each part of that ratio, we're going to put an x after it. 5x represents the number of wins that they're going to get. 1x represents the number of losses, and they're going to add up to 162 games. So what we can do now is we're going to solve for what is that x value? What are we going to multiply those by so that it keeps the ratio of 5-1, but that we actually get up to 162 games? Well, right now it's just a basic algebra problem. Right, we're going to add 5x plus 1x. That gives us 6x. We have 6x is equal to 162. Well, that gives us x equals 27. So now what we have to be careful of is the answer to this is not that they get 27 wins. Right? It says in a season, how many games do they hope to win? What we now need to do with this x value is plug it back in for the one that represents the wins. And in this case, it would be 5x. So what we'll do is we'll plug it back in. 5 times 27 gives us 135 wins. So if they want to keep that ratio of 5-1, they need to hope to win 135 of their games. So we're going to try that one more time here. So length of the sides of a triangle are an extended ratio of 4 to 7 to 9. What an extended ratio means is just talking about more than just one thing, right? In this case, we're comparing three lengths. So this is going to be sum 4x. This is going to be sum 7x. And then this one right here will be 9x. Right? I use x as my variable just to help us out, trying to figure out, okay, we know it keeps this ratio, but right, if you add 4 plus 7 plus 9, that does not add up to our 60 centimeters. So we know it keeps the ratio, but we have to figure out, okay, well, what do we have to multiply those all by? Some constant number. So we start just like we did the last one. We're going to take 4x plus 7x plus 9x, right? Because we're trying to get perimeter. So right, we add the sides together. That has to add up to 60x. Well, now that we take those three values, right, 4 plus 7 plus 9, that's going to give us 20x. 20x is equal to 60. And now one step further, right, we find what x is. Just like the last problem, that's not our answer. What we need to now do, it says, what are the lengths of the sides? In this case, we're actually going to plug it in for all three of them. So we're going to take 4 times 3, 7 times 3, and 9 times 3. And right now that we have all these values here, we have 12 centimeters for this side, 21 centimeters for this side, 27 centimeters for this side. And if you were to add those all up, right, 12 plus 21 plus 27, you could just double check that that does in fact give us our 60 centimeters. So some new vocab words coming up here. So proportion. A proportion is an equation that states that two ratios are equal. So right, we set two ratios equal to one another. That's called a proportion. And then we have these things that we call means and extremes. So means and extremes. So the means, bottom left, top right. Our extremes are top left, bottom right. Most of the time we're going to deal with them as a ratio equals another ratio. Not often do we deal like this, but so we'll talk about this one right here. So we have a couple properties with them. So properties of proportions. We have the cross product property, right? Some of you might know this as cross multiplication, right? It's saying that the product of the means is equal to the product of the extremes, right? Notice what's happening here. We are multiplying, let's get the highlighter out here, right? We're multiplying A times 5 and B times 3, and those are going to be equal to one another by this property. Our next one is called the reciprocals. The reciprocal of both ratios in a proportion are equal. Notice we had A over B is equal to 3 over 5. We can just take the reciprocal of each one, right? Flipping it over, B over A now is going to be equal to 5 over 3. We switch our means. So right, if we remember our means are bottom left, top right. What we're doing is originally we had A over B is equal to 3 over 5. We can actually switch these two. Notice we switch the 3 and the B, and that will still maintain those being equal to one another. So we can do that and it still stays equal. And then our last piece here is that you can add the denominators. You can add the denominator of the ratio to the numerator and keep equality. Notice denominator of our first one, we add it to the numerator. Denominator of our second ratio, we add to the numerator. This is still an equal statement. So those are our three properties of proportions. And so we're going to go over a couple examples here and then we'll be done for today. So when working with equivalent proportions, we need to figure out which of our properties they are using. So notice what they are focused on here is this right here. X over 6 is equal to y over 7. What ratio completes the equivalent proportion? Justify your answer. So I do have these filled in already, so we'll have to kind of hide the answer for a sec. Right, it wants to know if we have 6 over x, what's our answer going to be? Well, right, notice the answer is there for you, but let's think about what did we do here? Right, originally we had x over 6, and now notice we have a reciprocal. So what we're going to do is the same thing here. We take the reciprocal of y over 7, and we get 7 over y. Now last one here, right, we're looking here, okay, right, notice our right side, we have y plus 7 over 7. We notice, right, our denominator was 7, and we added it to our numerator. So what we're going to do is from our original one, denominator 6, we're going to just add that to our numerator, and that still makes an equivalent statement. So that is it for today's lesson on 7.1, talking about ratios and proportions.